Hi, welcome back. So I'm going to try to get through this recording without coughing too much. I'm still a little under the weather. The last time we were together, we worked on ratios and proportions, putting things into fractions and having those fractions equal to other fractions. And then we used cross multiplication and we solved for stuff and it was all fine. Well, now we're going to add the one little piece on top of it that makes it seem like it's oh so complicated. But it's not. It's the same thing, just more stuff to keep track of. And now there's shapes to stare at. Okay? These are the similar polygons. And similar polygons have the same shape, but not necessarily the same size. So it's slightly different from congruent, where it had to be same size and same shape. This doesn't have to be the same size, but has to be the same shape. Two polygons are similar if and only if their corresponding angles are congruent and their corresponding side lengths are proportional. That is, if you write the measures of the sides as fractions, those fractions are equal. Let's take a look at this graphic right here and see what it tells us. It says that ABCD is similar to WXYZ. And notice the little symbol for is similar to. It's the congruent symbol, except we took out the equals, because it doesn't have to be equal in size. Okay? Okay. So corresponding angles, we're going to be using the order of the name. A and W both come first, so those are corresponding angles, and so those are congruent. B and X would be congruent. C and Y are congruent. And D and Z are congruent. Okay, so we can list all those corresponding angles. The corresponding sides, notice, are in proportion. So we've written them as fractions. And those fractions all should be equal to each other. And it looks like they all equal 3, but let's confirm that just to make sure that that works out. So this first fraction says AB divided by WX. So AB's measure is 15. WX's measure is 5, and if I do 15 divided by 5, I get, all right, so that seems to work out. Let's do one more just to assure ourselves it's right. BC is 12, XY is 4, 12 divided by 4 is 3. Okay, so that does work out. Whenever we do this, we make a ratio of the sides. This value that we get is called the scale factor. Excuse me. If you ever go to the copy room and you push enlarge or shrink, that number, that percentage that you're shrinking or enlarging by, that's a scale factor. And so it's basically doing this to figure out how big or how small you want the thing to print out as. Okay? All right, so let's practice. I'm going to keep it zoomed out just a little bit so we can see everything because it's pretty widely printed. It says list all the congruent angles and write a proportion that relates the corresponding sides for each pair of similar polygons. We're going to do number 1 first, and I'm going to take a moment and I'm going to mark out which vertices are corresponding to which vertices. So in this triangle, DEF is similar to triangle GHJ. The D and the G are both listed first, and so those vertices are corresponding. I see E and H next, and so those vertices, those corners, are corresponding. And then F and J, those corners are corresponding. And so now I can write my angles. Angle D is congruent to angle G. Angle E is congruent to angle H. And angle F is congruent to angle J. Now I've got to list out the corresponding sides in proportion. That means I'm going to write them as ratios, and all of those ratios, those fractions, are all equal to each other. But I've got to figure out which sides correspond to which side. If I look at this triangle DEF and I look at the side that goes from the pink vertex to the orange vertex, that's going to correspond to the pink and orange vertex over here. Yeah? Okay. And we're going to repeat all the way around. I'm going to color code all of my corresponding sides so that it's easy for us to keep track of what sides we're going to be working with. And now that I know my sides, I'm going to go ahead and write my proportion. Now at this point, I have a choice as to what goes on top and what goes on the bottom. I can either write the side for the left triangle in the numerator, or I can write the side for the right triangle in the numerator. It doesn't matter which one you choose. So just pick one. Left or right? Which one goes on top?
Left.
The left one. Okay, yeah, that's typically the choice I make too. Okay, so the left is going to go on the top. That means the right is going to go on the bottom. And now, from here on out, as I'm writing the rest of these proportions, I need to keep it in the same order. Because if I don't keep it in the same order, I'm writing a different fraction value, and suddenly the world breaks. Ta-da! Feels okay? Do you need to see number 2 done? Or is this enough? This is good? All right. Okay, let's do 3 and 4. We're going to determine whether each thing is similar. If it is, we're going to write the similarity statement and the scale factor. Recall that the scale factor is going to be this value, so we should have some numbers in there if we're going to give it a scale factor. And if not, we're going to explain our reasoning as to why these things aren't similar. Number 3. Are they similar? Okay, I've got a couple people saying no, some people shaking their heads, and I had a few people saying yes. Let's go back up to the very, very top and let's double check our definition. Similar polygons have the same what? But not necessarily the same. In order for them to be similar, corresponding angles have to be, and corresponding sides have to be. Okay, looking back at these two shapes on number 3. Are the angles congruent to each other? No. The corresponding angles aren't congruent. Like if I look at the first one, all of them are congruent to each other, and that's fantastic. When I look at this one, I have these 3 congruent, but that one isn't marked, so I can't say it's congruent. And this thing, that thing's a right angle. Which means that angle is congruent to all other right angles in the universe, but not necessarily to these things because I don't know what those measures are. I could totally find out, right? Because this is a regular polygon and I've got a cool formula for it, but I don't really care what the number is right now. I just know that these are all equal to each other and to those 3, but not to these 2. Which means, is there any way that these 2 shapes are similar? No, and so our answer is no, not similar. And we have to justify. So I'm going to write the word because. Because why? The angles were not congruent. Very good. Perfect. Let's look at number 4. Similar, not similar. Similar. Okay, tell me how they're similar. Yeah, the angles. Yeah, look at our angle R and angle T. It's marked with the same number of markings. I'm going to go ahead and zoom in on that figure real quick. See, R and T have the same number. It's really small, but there's 2 of them in there. Q and S have the same number of little markings. They have 3. And P is shared between both of the triangles. Yeah? Which is totally possible. You can have a corner shared. So then these are similar? Okay. So yes. Similar. Okay. I don't have to similar. No, I spelled it right the first time. Okay. I don't have to write the reason, but I do have to write the similarity statement. So triangle, I'm going to go with the small one first. PQR. It doesn't matter which triangle you pick. I just happen to pick the small one. Is similar to triangle. Now I need to go corresponding. P corresponds to P. S corresponds to Q. T corresponds to R. And I know that because those are the angles that are equal to each other.
What did you put
It's a little squiggly. The same thing that you put on the top of congruent. Now I need the scale factor. I'm going to put the scale factor in the same order as my similarity statement. Because my similarity statement says PQR to PST, then my scale factor is going to be the side from the triangle PQR to the side from the triangle PST. And when I simplify that fraction, I get that value. Feels okay? Yeah? Good. Join me on the back side of the page. We're halfway done with our notes. You guys are awesome. If 2 polygons are similar, their perimeters, that is, whatever you get when you add up all the sides, that perimeter is going to be proportional to the scale factor between these 2 polygons. Overly complicated bag to open to get to water. All right. So if ABCD is similar to JKLM, then here's the perimeter of one shape. That's all the sides added together. And here's the perimeter of the other shape. All the sides added together. And that's going to be equal to, now check this out. Here's AB, and here's its corresponding JK. That's a scale factor. Any 2 of the sides. Here's a scale factor. Any 2 of the sides. Here's the scale factor. Any 2 of the sides. Here's a scale factor. Any 2 of the sides. Jess? Jess. All right, let's play with this. Pick your poison, 1, 2, 3, or 4. 1. All right. Number 1. Number 1 says, each pair of polygons is similar. Find the value of x. Now, I'm going to take a moment and try to figure out which sides correspond to which so that I know which ratio to write. Okay, so Now look at this angle, and that's going to go with this side, because that side is across from that angle. And over here on this triangle, here's that same corresponding angle, because they're congruent. And so those sides are corresponding. So let me just highlight those a little stronger so you can see it. There we go. I'm going to grab this side, which is across from the nothing angle. All right, there's those sides. And then this one will correspond to that one. All right, and now I'm going to look for 4 sides that I have information about, and hopefully I can relate them somehow. Okay, definitely going to target first the ones that I want information on, and we're setting up our ratios so it doesn't matter which one we pick to write first. Do you want to write in the numerator the triangle on the left or the triangle on the right?
Right.
The right. I heard someone say left. Go ahead and write yours on the left. We're going to write ours starting with the right. Okay, so I'm going to use the right triangle for the numerator. You go ahead and use the left triangle for the numerator. We're going to get the same thing, just you watch. But now that I've made this choice, I'm going to go ahead and continue that choice for all my other ratios, just to keep things nice and tidy. Make sure I did my arithmetic correctly, please. Yeah? Okay, good. Is there another one that you want to see? That when you look at, you're like, oh God. Yeah, it's exactly like yesterday. Except now you've got to pull your information off of shapes rather than it just be handed to you. We're okay with this one? Alright, then I want to look at the very last example, that's number 5 at the bottom, because this one deals with a perimeter. Okay, so it's the same sort of skill again. We're setting things up, but the setup is a little challenging. Alright, so if ABCD is similar to PQRS, alright, so I know that things are in proportion. They want me to find a scale factor. And notice how they're writing, how they want that scale factor written. They want ABCD to PQRS. Okay, so that means that the ABCD information has to be in the numerator. And then they want me to find the perimeter. Alright, so I'm going to take a look at this. The A's matches with the P, B with Q, C with R, D with S, because that's the order the names are in. Alright, so that means that this side corresponds to this side. I don't have a measurement here. But what do I know about the shape PQR? It's a rectangle, opposite sides are congruent, which means, as he stated, yes, that is 25. If I look at ABCD, I've got the same argument happening, and so there are all the sides for ABCD, and I don't know what the sides here are for PQRS, but I can put a variable. Now I can do some sort of scale factor thing. Scale factor is a ratio between 2 sides. And I have to put it in the order that they gave it to me. They gave it to me as ABCD to PQRS. So ABCD to PQRS. Writing that as a fraction, 20 over 25. And reducing it gives me 4 over 5. There's my scale factor. Now to find the perimeter, if you look at the very, very top of the page, the perimeter is found by taking this scale factor and setting it equal to the ratio of the two perimeters. Or again, we're going to follow the same order that our scale factor is in. So here's my scale factor equals, okay, now here's my perimeter of ABCD. And here's my perimeter for PQRS. And it looks intimidating because there's a lot of stuff. Yeah, but let's start combining like terms. I don't have anything to do here on the left. The right-hand side on the top is going to become 38? 68, okay. And the bottom is 2x plus 50. Which still looks intimidating, but it's a fraction equal a fraction, which means I can totally just cross multiply and solve. So 4 times 2x plus 50 equals 5 times 68. So 8x plus 200 equals 340. Okay. Subtracting 2x, or excuse me, 200, and then dividing by x. Help. $17.5. Said with a slight question in your voice because you're like, oh my god, it's a decimal. Okay, it's a decimal. Well, okay, so if you get that, you're like, oh my god, it's a decimal. Did I set things up properly? Yes. Did I combine those like terms properly? Yes. Okay, did I do cross multiplication properly? Yes. Did I distribute properly and multiply properly? Yes. Did I subtract properly? Yes. Did I divide? Well, I put it in the calculator, so that must be right. I'm good. Okay? So if you're ever looking at a question answer and you're like, that's what you should do. Just go back and just make sure that you did each and every single little step properly, and if you did, then you were right. That's it. That's all I had for you today.